Hello, good morning and welcome, and I should say good afternoon and good evening because we have a very international audience here today. My name is Stu Pringle and I'm part of the team here at Empire Engineering and I'm your host for today's session. I can see lots of people joining at the moment, so welcome to you all. I'm joined today by two of my colleagues at Empire, Karl Davis and Alan Marson. And we're also delighted to be joined by our very special guest speaker today, Morten Tobias Lind from COWI. Empire Engineering, we are an engineering consultancy supporting the offshore wind industry with advice, insight and technical know-how. We're headquartered in Bristol in the UK and we also have a London office, and as a team we can be deployed around the world. Now then, welcome all to today's session. Before we get into the topic today, and we're going to be talking about the Monopile, just a little bit of housekeeping. So this is our second crowdcast that we've done as part of the Foundation X Tech Sessions Live series. And you'll see there's a chat forum on the right hand side. I can see lots of people saying hello, Mark, Luke, Jacques, Eric, Alberto, so thank you very much for coming along. Please don't be shy, say hello, come and join in. We'll be sharing our screens during the session, so you don't need to do anything from your side. If you have a question, you can submit them to Ask a Question. And finally, very important, if anyone is struggling with audio quality, if you hit the cog at the bottom right hand side, the default is auto, which is HD. If you go down to 720 or 360, it'll be a much better audio quality, slightly reduced visuals. Okay. That's enough of the housekeeping. Very, very briefly, I'd just like to say thank you very much indeed to our sponsors, ITH Bolting and Wood Thilstead, who are supporting us throughout this Tech Session series that we're going to be running for the rest of this year. Right then, let's get on to today's session. Okay, so today we're going to be talking about how deep can the monopile go. And very briefly, at a high level, here's the agenda for today. So we'll meet the speakers, traditional view, situation right now, the factors to consider, and a little bit of crystal ball time, a look ahead at what the future might hold. Now then, you're probably thinking, why are we discussing this right now? Because the monopile's been around for a very long time. Well, there's very good reason. Let me explain. Back in May 2019, we published this article on our website. It was one of the first long-form pieces that we did, and since then it's had more than 2,000 people read the piece. And even last month, more than a year after it was published, still had 149 people reading the whole thing. In fact, they got 1 second quicker than on average, so they're obviously smart cookies. But in all seriousness, what does this mean? It means that we know this is a hot topic, we know there's a lot of debate, there's a lot of interest, which is why we thought we'd get some experts together and really get into it on today's session. Now then, I think it's probably about time we met our speakers for today. So I'd like to welcome along stage, along with me, Karl Davis and Alan Marson from Empire Engineering, and also Morten Tobias Lind from COWI. So let's meet our speakers. Hello, I can see Karl. Good morning, Karl.
Good morning, Stu. Good morning, everyone. So a little bit about me. I'm Karl Davis. I'm Managing Director of Empire Engineering. I've been working in offshore wind for a number of years now. I'm originally from New Zealand, and I embraced renewable energy after a brief stint working in the Australian coal mines.
Okay, right. Brilliant. Thank you, Karl. Alan, hello, good morning.
Good morning. I'm Alan Marson, Principal Engineer at Empire. I've been working in offshore structural engineering for about 15 years now. And one of my primary roles in Empire Engineering is offshore wind foundation concept design and selection, as well as some of the more interesting and exciting FEA stuff.
Brilliant. Thanks, Alan. Nice to meet you. And last but certainly not least, we have Morten Tobias Lind from COWI. Good morning, Morten.
Good morning, all. Morten Lind. I have about plus 20 years in offshore engineering, starting off early days in the oil and gas, and soon moved on to renewables. Now technical director in COWI, sitting in the headquarters in Copenhagen.
Brilliant. Welcome, Morten. Thank you. Okay, I think we've got the niceties out of the way. Let's get in with some punches, shall we? How about this for a little start? The traditional view. What have I said to you? What have I said to you, panel? That the monopile is limited to shallower water, and that's it. It can't do anything else. What do you make of that as a statement? And I'm going to go to Karl first.
So I guess going back 10 years, the general view was that, the monopile was in relatively shallow water, so 20 to 30 metres of depth. I guess it was probably on the Rampion project where Morten and I worked together a number of years ago. We started trying to push that a bit further and found that we could really get out to, I think Rampion we ended up in 38 metres or so. But previously, it's always been seen that jackets were needed when you went over, a certain level, and 30 meters was kind of the arbitrary level we saw back then. But now we seem to be pushing out a lot further.
Okay. So Morten, Karl there, he mentioned that you two worked back in the day. I'm sure that was probably, you don't really working with him really, but no, I'm sure that was great. But come on, tell me a little bit more about that. What were you doing? Was it just monopiles? Was it a mix? What was happening then?
I mean, you mentioned now Rampion. Yes, Rampion was located in the south of UK, outside was it Brighton, I recall. Of course, that project started off with also some very deep positions that were then later disbanded because that would have required jackets. Looking at it today, 5 years after, we could easily have put a monopile in there with today's technology, but this was 2013, 14, yes. So that sort of sets the standard. It's pushing the boundaries all the time. And I think when asked about what is the water depth, yes, early days, yes, 20 meters, 30 meters was the max in 2010. We said we can't push this further. Now, I think we're at somewhere double that height, perhaps. Okay. It is really within not far technology, but that is where it's going.
Okay, and that's all happened, relatively recently.
I would say we can put monopiles in at 45 meters now and not question anything, and this is only 5 years ago. We couldn't. We would not even go there. That would be too tricky.
Okay, interesting. Which I guess brings us very nicely to talking about the situation today. So you mentioned there that the technology has advanced and really sort of the picture's changed. So come on, right now. What do you think are the limits in terms of the monopile? Who will we go? Karl, what do you think? What do you think of that? Now, what's the situation?
It's not a simple answer. Sorry, I'm starting to sound like a politician here. Because you've got a number of competing factors that we consider. In some ways, the technical advances we've made make our lives easier. We're making bigger diameters and we can build bigger structures. But the turbines are getting bigger as well. And with bigger turbines, we have conflicting kind of requirements. Those turbines are heavier and are harder to deal with. Now, we can fabricate up to a 12-meter diameter monopile. And to put that in context, that's the diameter of the length of a London bus, and we're pushing out we can do these really big monopiles, but there's still plenty the monopile can do. I think the fact is that we really look. Oh, there we go.
There you go. Just for reference.
Thank you. In terms of design, our design methodologies have improved a lot in terms of what we can do. But the fact is, we really want to consider. We have to look at the design. What can you design to meet the requirements of these big turbines in those deep waters? Our fabrication limitations are really important. What can we build? Can you transport it? And can you install it? They're the kind of the restrictions and limitations that we need to look at.
Okay, so I think that we put the bus up as a bit of a joke there, but I think there's a point. We're talking about putting things the size of London buses out to sea, and it's getting a bit serious. But because with that increase in size, there's creating some bottlenecks, isn't it? You're really kind of hitting the limitations on the fabrication side. I know, Martin, when we spoke the other day, you had a few thoughts on that.
Yeah, of course, we can come back to some of the design parts, but of course on the fabrication side itself, yes, anytime you fabricate something that has a 12-meter diameter, you also expect quite a bit of load on it, which has to be taken up in the wall thickness. And wall thickness is, of course, are nowadays creeping up. Even though you can do a lot with the fine element, you still have to take up the membrane stresses and the bending around the mud line and just below. And of course, these wall thicknesses we're facing now is new to the industry. Just even looking at the US, I mean, they're not even close to manufacturing plates the size of 80 millimeters or so. It's completely new for them. It's completely new ground in US. And here in Europe, we are looking at 120 plus millimeters on some of these sections that we are putting into the monopiles. You can say, yeah, it's just a thicker plate, but something happens when you fabricate thick plates that you're not always in control over. And the requirements for doing your fracture mechanics, probably your testing for CTODs, and not only simple Sharpies that are only indicators, but when you move into sort of crack tip opening displacements on your welding techniques on very thick plates, that's new ground. And you can not only put it on the fabricator saying it's your job, fix it. No, it's actually the designer who has to anticipate what is actually going on in the structure when I weld two sections of plus 120 millimeters together. What is actually the consequence of that? Because you can only require so much from workmanship at the fabricators. You have to anticipate yourself. What are the consequences here? Because we've been living with slender monopiles for so long and simple SN curves that we can predict what will happen. But going to thicker wall thicknesses, I mean, we're moving very fast into probabilistic fracture mechanics, because you don't know what happens in plus 120 millimeters wall thickness. So I'm only saying that's part of the fabricator's sort of dilemma here. We can actually do the 120 millimeters. It's just quite costly. And there's also the engineer's task to actually foresee what happens is much more profound now.
Sure. No, good
Morten, you raised an interesting point there. Fabrication in the US. Do you think we're going to see monopiles fabricated out of US facilities?
Of course we will. At some point. At some point we will. And the US is a massive market. The potential there is just enormous. But to gear an industry into fabricating thick plates to the standard that we have in the EN standard is not simple. So that's I believe another 5 or 10 years from now before you see that. I know some fabricators in Europe, of course, trying to set up in the States, but this technology transfer is not so easy. That it's more than just machines. It's also about a whole mindset of how to fabricate these plates here. Sure. Not so much fabrication, but also the welding and the transport and the testing.
Well, yeah, I think we definitely discuss those points as well. Look, that's fascinating insights. I can see Alan scratching his chin down there. Let's bring you into the conversation, Alan. Because it's something quite close to home for you, isn't it?
Yeah, indeed. I mean, I think we're talking about the concerns of 100, 120 mil thick plate, but a lot of this is driven by the sort of existing D over T ratios. So we're limited on D over T in terms of applicability of codes and what's expected. But actually, I think that this is an area where we can try and push that a little bit, because the D over T on a 12-meter monopile is quite a significant lower limit on your thickness. And I think that we can certainly do more research, do more work into the way that the sort of 10, 12 meter monopile reacts to thicknesses of 70, 80 millimeters instead. So pushing that D over T limit out to 150, 160, or potentially further. And even I've had discussions with a client who's actually in the webinar, I should point out, over alternative methods like adding some form of stiffening, which obviously raises its own issues. But instead of just a standard plate, some form of stiffened monopile plate, just again to allow for slightly thinner walls and overcome those D over T problems.
Well, if they're in here, they can reveal themselves in the chat bar if they want to say who it is. Alan, that's brilliant. Okay, so look, there's a few things we're starting to unpack here. We talked a little bit about the fabrication, but transport's an issue, isn't it? Who'd like to grab that one?
I'll jump on transport. Why not?
Go on.
Well, for a start, anyway. So obviously the weight and length limitations as we get into deeper waters. So as soon as you start hitting these big monopiles in deep waters, you're talking 100 meters plus of monopile, and weight limitations. Choose a number, but you could be looking 2,000 plus tons, and what vessel are you going to use to transport that becomes really interesting. We've seen lots of movement in the market in terms of what vessels are available, and what can be done. I think like OHT's Alpha Lift is a really interesting vessel at the moment because that they're able to transport 8 or 10 big monopiles. But as we go into even deeper water, even a huge vessel like that perhaps becomes limited, and how big our vessels need to be and what our method of transporting becomes really an interesting question, because it's not just a matter of fabricating and designing, it's how do you get it out to site.
Yeah, good points. Anyone else like to pick up on transport?
Well, I was going to say a lot of the work that I've been doing recently, or Empire have been doing recently, we're looking at the integrity of the monopile during transportation, and the longer and the heavier the monopile, the more complicated that becomes in terms of the overhangs on the vessel, the spans, the local stresses induced by the sea fastenings, and especially just going on to an earlier point about trying to push the D over T ratios. You're then putting yourself in a position where you've got a heavy weight on quite a thin plate. So you've got issues of your support conditions and stability.
Mm-hmm. Absolutely. Okay. And Martin, you mentioned...
There's also another point here. Sorry for interrupting, sir, but of course now the big monopiles, they are a vessel themselves. Fit an engine to it and you can sail it to something. But this has been done before also in UK. Of course, this was on sites that were much closer to shore, and you're more in control over what happens. Of course, if one of those gets adrift, you don't know what happens. This has been done also with jackets in the oil and gas industry, where you either, of course, offload it off a barge into the water, but why not do that from the shoreline? I think that will come eventually, because as you mentioned, Alan, there's so many complications about the integrity during transport these days, sea fastening, local plasticity issues on the monopiles, etc. That of course the clients are very concerned about. Some of these issues might be overcome by changing the mindset of how you transport it from fabrication to actually installation site. I know, for instance, let's go back to the US thing. If you fabricate monopiles in Europe that you are intent to install in the US and you want to go through the Atlantic, okay, that's maybe stretching it a bit too far nowadays, but eventually with the given technology, maybe floating out is something that should be looked at.
That's certainly been done, Morten. I don't know if this is true, but there was a point where a few projects had tried this, and everyone that had tried it had lost a monopile that had sunk one. That might be an old wives' tale, but
anyone in the chat like to put hands up on that? Anyone? Any stories people want to share?
So that's an interesting one. There's an interesting question that's been popped up, Stu, if you don't mind me interrupting.
Go for it.
Yeah. So Demetrius, the first one from Demetrius on flanges. Do you want to throw that out?
Sure. Do you want me to read it out? So,
yeah, that'd be great.
Is that the MP to TP one?
Yeah.
Okay.
Yeah.
Okay, so Demetrius has asked, what about the MP to TP flange interface? Is it going to work for larger diameter piles, or do we need a novel solution? That's what Demetrius would like to know. Panel, what do you say to that?
Well, I think we certainly need to look into novel solutions. When you're out to a 12-meter diameter pile, either the number of bolts or the size of bolts, I mean, working with sort of M72s or something like that is a serious challenge. So I certainly think it's an area where it needs investigating further, the novel and different ideas.
Okay, interesting. Anyone else? Any other thoughts on that one?
Morten, what are your thoughts on that?
Just a quick one here. Yeah, of course, we need to get away from these flange solutions somehow. I mean, of course, they have some advantages above the grouted connections, but and nowadays we also see new solutions popping up, some of the patented, etc. But I think yes, why not crimping two pieces of steel together or use some sort of a swage technology? I know it's large diameters, but it's also just a challenge. It can be. It's been done many times in oil and gas on smaller diameters, but since it is a customized item here, you cannot really reuse anything. So why not swage it all together and into one piece? That's at least a solution. But there are other technologies. I would say flanges on the long run will not work.
Okay,
there you go. Flanges in the long run will not
work.
I like it more.
Quote unquote. Lovely. Okay, so we've talked about fabrication, we've talked about transport. Naturally, next thing would be installation. It's going to be easy, isn't it? These big monopiles.
Yeah, why not? I mean, so at the moment the question is, with the biggest monopile you can fabricate and transport, as I understand it, there's not a hammer big enough to put that in, and so just hammer technology alone for driving these things doesn't really exist. And I think maybe Mink and the IHC guys I'm sure they've got some views on that, but as of today, there's not a device on the market big enough to put in really big monopiles at really deep water depths.
Okay, there you go.
Yeah.
Anyone else got some thoughts on the installation side of things?
Same thing here. Of course, having a huge monopile, you're lifting onto a vessel, and then from the vessel into the sea, you can skip a couple of operations by floating it to site. But then comes the issue about upending it at location. That is also a tricky exercise. But if it's done in the water, actually you can actually do a bigger monopile, upending something in water. Then back to installation. Yes, I agree with Karl. Hammers are not the solution here. And also some of the new solutions we're seeing is either drilling into, if it's rock, then of course you need to drill through it. But with a technology where you drill, install, maybe refill with concrete or some other sediments is maybe a better solution. But also vibro installation, vibro driving piles nowadays. It's actually a well-known technology on land where you have sheet plates or other that you normally vibrate, and it's picked up the last 10 years. But it's a really good solution, at least for this where you have some good sands or soils to vibrate into. But also that technology is taking out a huge burden on providing hammers big enough. So I think vibro installation hopefully is taken over the next 10 years or so, and then maybe having new technologies on drilling and driving.
Fascinating stuff, Martin. And I tell you what, gentlemen, we are generating some serious debate down the right-hand side as well. So this is obviously quite a topic.
I noticed the comments back and forth about driving fatigue. Because again, as a sort of analyst here, right, the side of the driving fatigue for the larger monopiles and the risk of refusal. is certainly an area where I think there becomes concerns. So yeah, it was interesting to follow the discussions going on there.
Yeah, and also coming to you have a more like now they're turning into plates, and
yes,
if you have a buckle in your monopile, because it doesn't have the stiffness locally when you drive through and then you hit an obstacle. So actually, a bigger monopile is actually raising the susceptibility for buckling when you do the impact driving. So that's another reason for maybe trying new solutions. Yeah.
Brilliant.
Where you're not forcing it through, but actually having it sort of sink in at its own weight and speed.
Okay.
I'm starting to be concerned that Morten's got stock in some vibro hammers at the moment. But
Well, I would say that's technology that's really promising, I believe.
I think in this discussion it would be remiss of us to just talk about monopiles completely in isolation, because at some point this jacket's got to enter the discussion. There's a trade-off, isn't there? At what point does the monopile start to no longer be the option and jacket becomes more interesting? Go on, Karl looks like he wants that one.
Okay. Well, I mean, it's a really interesting question. So the jacket, there's a question of feasibility trade-off and cost trade-off, and my view is it's just a question of feasibility. We'll keep pushing monopiles until the technology won't allow us anymore, because jacket costs, they seem to be much higher than people think. Most of the projects that have had a crack at doing serial production of jackets have had issues with big cost overruns or difficulties producing them as serial production, and I think just from a project risk point of view, people really will end up going for monopiles wherever they can, because they're a known technology that we can produce lots of. Whereas jackets, you only really want to use if you can't make a monopile work. And that question is, just how far can we push the monopile out on certain locations?
Mm-hmm. Good point. Yeah. Good points. Anyone else on that? Any other thoughts?
I would say it like this. Of course, if you sit as an investor right now and need to install something in a couple of years from now, and you need to decide on what technology you need to use, then of course you have to take a decision. And if monopiles are borderline, okay, you want to de-risk your project. But if you look 10 years into the future, yes, and technology will take monopiles to deeper locations that there is today, then of course maybe there's an incentive to explore that, because the monopile has an advantage over jackets. Karl mentioned price and complexity. That's right. They are difficult to fabricate, and it's only few locations you can actually do these jackets at a good enough quality. But the monopile is of course superb for wind, because it's circular, right? So the load from any direction, you more or less predict what will happen, and that's what happens in offshore wind. So that's why it's much easier to do the analysis. It's much easier to understand exactly what you need to do. But the jackets, of course, when nowadays when you are facing 50 meters or thereabouts, you really don't have a choice anymore, and they are forced into to do jackets, but they are complex. But the weight on a jacket 50 meters is only about 1,500 tons or so. So they're actually comparable. They're just much more complex to fabricate and install.
Okay.
So
interesting.
Just one other point that's not been raised yet, I think, is to do with the sort of natural frequency. And obviously, as you increase the water depth on a monopile, you're starting to hit natural frequency resonances that you obviously are very important for avoiding for your turbines. Whereas jackets are stiffer structures in general, so that again impacts on the choice, and it may well be that your decision between a monopile and the jacket depends on how much you can tweak and control the natural frequencies.
Good point. Now, I'm conscious of time, so let's keep moving. You know that I like to ask awkward questions, so I think we need to get the crystal balls out and talk about the future. But before we ask the panel, I think it's about time we had some audience participation. So, we've got a lot of people with a lot to say, clearly today. Why don't we have a little poll and let's see what the audience thinks is actually how deep the monopile can go in the future. So if everyone who's watching clicks on the little poll button that's appeared at the bottom of the screen now, you'll see that we've got a little Ask the Audience participation feature. How deep do you think the monopile will go in offshore wind? And you can vote. So if you click on poll now, you'll be able to see in real time all the votes coming in.
Here we go.
Here we go. So we've got an early lead at 55 to 70. No one's got 100 plus. So let's just keep this running and see how many votes we get. If anyone can't see the poll, if you click on the polls button that's appeared at the bottom of the screen, you'll be able to see the poll there. So here they come. I'll just leave it open. Someone's gone big. Yes. Good. Good. Here we go. Brave people. That's what we like. Big and bold. Okay, so I'll leave it on for a few more seconds because there's still votes coming in. But it looks like that 55 to 70, which is more than has happened so far, is coming out as the most popular. Any thoughts on that, panel, before I ask you the same question? You just holding back. That's fair enough. That's fair enough. Okay, well look, I think we're just about slowing down now.
So my view is, Stu, we've got a very enlightened audience. People seem to have a pretty good feeling about where this is going. In terms of who we've got watching today.
Okay, so come on, Karl, on the spot. How deep are we going to go?
Okay, so my crystal ball, it's close enough.
Are you on the whiskey already? Surely not.
It's a nice day in Bristol. I was thinking more gin, but okay. I'm thinking that we can probably get some of the smaller turbines out to maybe 65 meters. The current 8 megawatt kind of size turbines. I think push them out to 12, even maybe 14 meters diameter, and you can probably get out to 65 meters. Because your D over T ratios mean that you end up with a really thick monopile anyway, so loads actually don't concern you so much. And so the fact that you're hitting some resonances from the turbines, you can actually deal with that a lot easier, and so the loads aren't bothering you so much, and you can probably go quite deep with those smaller turbines. But I think as we go to the bigger turbines, the 15s, maybe even the 20s, if we want to be going out that far, I think you'll see that coming back in a bit shallower, because those turbines are going to be so much heavier, so much more difficult to deal with from a design perspective, that you'll have some limitations there that actually, for the really big stuff, you won't go quite as deep, and you'll come back to your sort of 50, 55 sort of meter ranges. That's my gut feel anyway.
Interesting. So you think it's going to go out and then actually come back in as turbine technology changes?
Yep, I think so.
Okay, right then. Who would like to follow up on that? Because that's quite a statement.
I can chip in here, but because I think I tend to agree with you, Karl. We also have to look at the market trends here, and there are also other technologies on the deeper locations with the floaters nowadays, etc. That also are competing on the same sort of industry. But of course, there is sort of a max out on the water depths. But we also need to consider here, of course, now we're coming into a period where a lot of wind farms has to be renewed or closed and refurbished with new turbines. So that itself is also actually a substantial industry. Now you can fit in a much bigger monopile, fitting in a much bigger turbine at the water depths we knew 20 years ago. So that, of course, will drive part of the technology. Another one is going to even deeper locations. Yes, and this is what we're talking about today. But I believe also maybe 70 meters or so, and then the competition will probably be too hard. Now, as Alan mentioned about the frequency, yes, there are ways to deal with that, but and you have to fit in technology and dampers, etc. But at some point that will also be too expensive at some point. But maybe 70 meters as we're facing today, I feel is a realistic water depth. And of course, famous last words, you'll probably end up at 100, right?
Okay, excellent. And I think, Morten, when we had a chat last week, you mentioned you were looking at your particular geographies like Hawaii, Japan. There's opportunities.
Course, we need to understand that Africa is a large continent. South America is also a large continent with that needs offshore wind to some degree. And of course, that hasn't been, we haven't been there yet. But of course, the water depths there are also quite big. So, of course, they will take our technology and transfer it to these locations first. But the need for energy in these two continents, of course, also will drive the technology because it'll be a much bigger industry. The cake will be bigger. The pie will be bigger, meaning more money into it. So that will drive this technology further because it's a known technology that doesn't require a lot of new entries.
Fair point. I think that's really interesting.
I'm all up for a fact-finding mission to Hawaii to work out.
There's a surprise. Why am I not shocked by this great news?
Alan taking one for the team again. Yeah.
Alan,
Nice. Alan, anything to add on this one?
Not particularly. I think that predictions are particularly dangerous things to make, especially about the future. I think that
well, if it's about the past, Alan, it's not a prediction. I'm sorry.
Funny quote ruined. So I think that I think that there'll actually be a lot more focus on life extension, on potentially larger turbines on existing structures.
Okay, very good. Right. Everyone, we are very over on time. I know there's been lots of questions asked. So look, what we will do is we will make sure that we respond to them over the next couple of weeks through our channels. Follow Empire Engineering on LinkedIn and we'll make sure that questions are answered. But as for today, I think that's probably, we have to call time at this point. So I would like to say thank you very, very much for all our speakers for joining in. I'd like to thank you, the audience, for taking part. It's been really, really great debate. I hope you've enjoyed it. I'd like to thank our sponsors, ITH and Wood Thilstead, for supporting this initiative. Please keep a lookout on email and on our website and on LinkedIn. We will run the next tech session on the last Friday in August. So we'll be releasing the topic very soon on that. If you would like to talk about any of the team here at Empire about what you've seen today, you can see our contact on screen now. But for now, today, that's goodbye. And I hope you've enjoyed it. Feedback very welcome to contact at empirengineering.co.uk. And we look forward to chatting with you all next month. Thank you all.
Thank you very much, everyone.
Yeah.
Thank you.
Yeah, thanks.
Have an enjoyable weekend.